Guys, Assalamu alaikum. Today I am going to discuss moment of inertia and an important theorem that is parallel axis theorem. So let's begin. Suppose we have an object with irregular shape, and let's say this is the center of mass of the object, and there is an axis that passes through the center of gravity, and we have another axis that is parallel to the axis of PQ, that is CD. So we want to calculate moment of inertia of this object around CD. That means we want to calculate ICD equals to what? So we can calculate this moment of inertia around CD by parallel axis theorem. Why this is called parallel axis theorem? Because here these two axes are parallel. That's why this theorem is known as parallel axis theorem. So, what is the theorem? The theorem is ICD is equals to IG plus MH square. Okay. So, what is IG? IG is moment of inertia. Here, IG is moment of inertia around PQ. And what is ICD? ICD is the moment of inertia around CD. And we want to calculate this. And H, what is H? H is the distance between two parallel axes. Now, let's see how to prove this formula. So at first we need to take a small particle here, uh, which mass is mi, and distance from the axis PQ is xi, and distance from CD is h minus x. H minus xi. You can see the total distance is h. So if this is xi, then this distance is h minus xi. Now we know that inertia of a particle is mi xi square. Here xi is the distance of the particle from the axis PQ, which passes through the center of gravity or center of mass. So we can say summation of mi xi is equal to Ig. Why summation? Because the object is the combination of so many particles like this. That means like this one, like this one, like this one, like this one. So there are so many particles. So if we want to calculate this inertia of this whole object, we have to sum or add the inertia of this little particle. That's why summation sign is used. Now, for CD, ICD, this can be written like this, mi h minus xi whole square. And here we also put summation sign. Now, how to evaluate this expression? We can use algebraic formula, that is h square minus 2hxi plus x square I. Then multiply this mi h square minus summation of mi 2hxi plus summation of mi xi square. So here h square is a constant that doesn't depend on the position of the particle. This is fixed. So h square can be written here. That is summation of mi. And here also 2h is constant. So 2h should be written there. Mi xi plus ig. We know this is ig here. This is ig. Now, summation of mi means total mass of the object. So we can write this like m h square minus 2h into 0 plus ig. So finally, we have the formula ICD equals to IG plus MH square. This one is very helpful for finding inertia, and this video is actually part one, and I will sorry part one, and I will uh, post another video that is part two and part three. So let's see uh, why summation of mi xi equals to 0. The question is why summation of mi xi equal to 0. Why? I can show this with an example. Suppose we have an rectangle. We have a rectangle. Please forgive my accent. I am new in making videos, so I have too many errors. Hope you will forgive me for this, and I will try to improve myself uh, within the time. Now let's see. Here, this is the axis that pass through the center of mass. So we can say the mass of this square is distributed equally around this axis. Now let's take a particle that is mass of m1 and distance is x1. As the mass is uniformly distributed, we hope we can find another particle that is also mass m1 and distance from this minus x1. Why minus? Because this is the right side and this is on the left side. You can imagine this like a number line 0, 1, 2, 3, -1, -2, -3. That means this is positive distance and this one is negative distance. So if we multiply this, then we can find m1 x1 and this one minus m1 x1. So if we add up this, we can see that the result is 0. So that is not only for this particle. You can take another particle here, another particle here, and you can see that the sum is also 0. So overall, we can see that summation of mi xi equals to 0. If x is calculated from the x is calculated from the axis that pass through the center of gravity. Otherwise, this will not 0. Say if the axis pass through there, then summation of mi xi must not be 0. It should be only 0 if the axis pass through the center of mass. Okay. So this term is also known as moment of mass. You can see this moment of mass. So hope all of you have understand the parallel axis theorem and the proof. Now I will show you an example of use of parallel axis theorem, and in my later video, that means part 2, part 3, I will show you some other uses of parallel axis theorem. So suppose we have taken a coin. This is a coin, and we want to calculate its moment of inertia about the tangent that is perpendicular to the surface of coin. That means this axis is not on the surface of the coin. This axis is perpendicular to the surface of the coin. So to calculate inertia about this axis, we have to take another axis that is parallel to CD and that pass through the center of mass. That means this one. So distance between these two axes equal to radius. That means here we can see h is equals to r. Now, what is Ig? We know Ig is equal to half mass into radius square. Okay, half into m r square. Hope all of you know this formula. Then now ICD equals to Ig plus n h square. That we have already proved. Then now Ig equal to half m r square plus m r square. So we can write this 3 by 2 m r square. So ICD equals to 3 by 2 m r square. So thank you all, and I will discuss this parallel axis theorem in my later video, that is part 2 and part 3, and I will show you some other examples where parallel axis theorem can be used to determine moment of inertia of an object. So from now I am taking break. So Allah Hafiz. See you soon.